Yo, what's up, man? What up, man? It's your boy here again, man. You know, So we have a question right there, man. How the question say? The question say, integrate the following. These are integral. We have to integrate. So let's get started, man. What was the time? Let's get started. So the first question, if we start to the first question, if somebody give an integral, and then this is a trigonometric integral, cause all of them they have a trig. Look, for the first one doesn't have a trig, it's okay. I think I should have say this, man. I want to say integral of, excuse me, let's say sine of fx. So integral sine of fx. This is question number one. Sine of fx. Okay, so integral sine of fx. So somebody give integral sine of fx dx. So what you do, right, in trigonometric integral, whenever you have an integral and then you have a trig and then function, what you do is say 1 over, take whatever it is in front of the trig, differentiate. What is in front of the trig for this case? Fx. So say, when you differentiate fx, what we're going to get is f what? f of x dash means the derivative. So here the answer is going to be 1 over derivative this, which is going to give us dash. And then when you integrate, now then you integrate the whole. When you integrate sine, you get negative cos. And then write exactly the way how it is. You see what I'm saying? So that's how you integrate the first one. But remember, excuse me, no f of x, my apologies. So, and then you say, when you integrate sine, you get cos f of x, and then you always plus constant. So if somebody give me integral, let's say cos m of x dx. So what I'm going to do is say, okay, I'm going to differentiate whatever is in here, means it's going to be 1 over. When you differentiate m of x, you're going to get m dash x. And then when you integrate the whole, this is integral, of course you get sine. And then write exactly m of x. But a plus constant. Why? Because there's no limit. There's no limit, man. So that's how you do. Easy. For example, so the first part we done already. For example, somebody might give you something like this. So the first part is done. So somebody might give you something like this, for example. Somebody give you something like integral, let's say integral of, let's say sine and then x squared plus 2x dx. So we're going to use the same tactics, man. So what we're going to do, I'm going to take all of it and differentiate. So 1 over the derivative of whatever is here, which is x squared plus 2x. And then when you integrate sine of f of x, this is like f of x. So when you integrate sine of f of x, I'm going to get negative cos. So it's going to be negative cos of exactly the way how it is. And then you plus constant. Why? Because we don't have a limit. So that's how you derive normal integral. So the first one is done. See what I'm saying? Now we go for the second equation. So the first question is done. So I'm going to write the first one is done. So, okay. So somebody, let's take some few more, man. So somebody, for example, somebody give integral. Or let's say sec square. Sec square, and then let's say e x squared dx. So we're going to use the same strategy, right? What we're going to do, we're going to derive whatever is here. So we're going to say, okay, let's derive here. We say derivative 1 over, excuse me, has to be 1 over derivative of e of x squared. And then when you integrate sec squared, look here, man, you have to go to integral table. If you don't know how to integrate table, right? Remember, when you integrate like the reverse of differentiation, so we know when you derivate normal tan of a function, we get sec square of a function. So it means we integrate sec square of a function, it always takes back to the tan of a function. If we differentiate sine of a function, let's say g of x, we're gonna get cos of a function. So when you integrate cos of a function, the answer is going to be sine of a function. And that's what happens. You know what I'm saying? So we know when you differentiate tan, we get sec squared. Means if I integrate sec, I'm going to get tan of a function. So for this case here, excuse me. So what I'm going to do, I'm going to say, okay, so the first step, it has to be 1 over for any trigonometric integral. You say 1 over, and then you derivate to whatever is in here, whichever is in here. So 1 over, and then we're gonna integrate all like integral sec square of a function dx. Like this is a function. So what happened? We know when you differentiate tan, we get sec square. So if we integrate, we know if we derivate normal tan of a function, we always get sec square of a function. Means when you integrate this now, the answer is going to be tan of a function. So what happened? Means if I integrate sec square, it's going to give me tan of a function. So here, when I integrate sec square, so the answer is going to be what? Tan of a function. What is a function? Our function is ex squared and the plus constant. That's a final answer, man. Easy, man. You see what I'm saying? So that's how you differentiate some of the trig integral. So let's go for the second one, right? So this one is done. We're going to do the second equation now. Second equation. Woo, man. So now let's check that one right there, man. So we have an integral sec, and they have a ln of x squared dx. So man, don't get like, man, I'm confused, it's so big now. So what you do, so okay, what is this? This is like f of x. Why? It's like integral of sec square, and then we have a function dx. Just something like that, because whatever is in front of the trig is the function. So we know, okay, if I had to integrate this, I'm going to say 1 over, and then you have to derivate whatever is in front of the trig. So in front of the trig, right? So it's going to give us f dash, because when you integrate f of x, you're going to get f dash, and then when you integrate the whole sec, it's going to give us tan of a function, and then plus c. Why we say plus c? Because we don't have a constant. But if you have a constant, we have to substitute our limit. So that's the answer. So for this case now, what we're going to do, we're going to differentiate this. It's like saying 1 over derivative of ln of x squared, and then this is like, now this, so 1 over whatever is in front of the trig, so we get the answer, and then now it's like, now this is like f of x, so it's like you integrate sec of f of x. So 1 over face derivative we have, so 1 over face derivative, and then we multiply by tan, because when you integrate the sec of a function, we get tan of a function. So it's going to be tan, what is a function? Ln of x, ln of square x plus constant. So this is going to be our answer for number 2. But now you have to break this out. So I'm saying, so how are you going to do this? It's easy, man. So let's see how we can differentiate ln of x. So we know when you differentiate, look here, when you differentiate ln of a function, we know what we do. We always derivate whatever is in here. You write on top, and they say over, write exactly. Easy. So I'm saying, very easy, man. So it's like if somebody give, for example, derivate ln of sine of x. So what I'm going to do, I'm going to derivate whatever is in front of the ln. But when you derivate sine, you're going to get cos. And then always over exactly what is in here. That's how you derivate what? Ln. And then cos over sine equal to cot of an angle. Easy, man. Or let me check. So for this case here is easy. So I'm going to say, okay, so derivative of a, so I'm going to say, okay, so I'm going to write this. So we don't need this, right? We don't need it. I can just erase. So I can do here. So derivative of ln of a function. What is a function? X squared. So what I'm going to do, I'm going to derivate whatever is in here, which is going to give me 2x. And then over, I'll write exactly, which is x squared. But then you can simplify for x1 for x1. So it's 2 over x. So when you derivate this, is going to be 2 over x. So 2 over x. So then finally, it's like 2 over x. So it's 1 over 2 over x. And then multiply by tan ln of x squared plus constant. But now this is going to go to the top. So I'm going to rate this one. So now it's like you have a 1 divided by 2 over x. So what that means? This same is say 1, but when you say 1, it's like 1 over 1, and then you multiply, but you flip it. x over 2. So this is going to give us x. 1 times x is x, 1 times 2 is 2, so it's x over 2. So here 1 over 2 over x, I'll say x over 2, x over 2. So finally, when you integrate sec square ln of x square, these gonna dx, these gonna give us x over 2, mean this is x over 2, and then we're gonna say tan ln of x square plus constant. Man, that's how you do this, man. You see what I'm saying? So now we go to the question number 3. So I'm gonna rate this. We don't need it. You know what I'm saying? It's done. Number 3. Number 3 is easy. Man, I didn't mean to write that question like that because this doesn't make sense. So, for example, somebody give you, ignore number 3, man. It don't make sense. So just this one, just ignore. Crazy question. Okay. Number 4. Number 4, they give us integral of sine cube 5x dx. So how are we gonna solve that, man? It's easy, man. Let's see how we can solve that. So now we say, let's go. So we say this is easy. So we want to say, first and foremost, man, I want you to know double angle trigonometry. Double angle trigonometry. And these are double angle trigonometry. When you say double, means anything double is the same thing twice. So if somebody give, for example, double angle of cos, double angle, let's say theta or x, means double my angle. This same, say cos square, you divide by 2 this one, x, because look, this is double 2 times double something. So say cos of double angle, cos square, and then split into 2. So it's like x, and then you minus sine square of angle. So this is, you need to know this. Before you start to solve this stuff, you have to know this, man. You see what I'm saying? So let's see how we can solve this, how this is going to relate to this. So now we say, and then I could have changed this. So this is the key is going to save your life. And make sure you start with the cos minus sine square. Or if I don't want to write like this, of course, okay, but I know I can replace this sine. What is sine square? So cos square is like 1 minus sine square. Minus sine square. What does that mean? How do I know that one? From the trig identity, sine square plus cos square always equal to 1. So if I had to replace, what is cos square? Cos square means 1. This is go over. It's going to be 1 minus sine square because you can take this over. So it's going to be cos square equal to 1 minus sine square. So that's what I did here. So I replaced cos square by 1 minus sine square. You know what I'm saying? And then it came in here. So that meaning 1 negative and negative, negative 2 sine square x. So this is cos double angle. So cos double angle, it could be written as this or as this. You see what I'm saying? So it depends how or where you want to use. But I'm going to show you now how and why do I have to change. On the next example, I'll show you now why do I have to do what I have to do. You see what I'm saying? So now, or if I don't want to do it, let's say I want to have a same cos double angle, which is this one, cos double my angle. Let's say I don't want to have a sine, I want to have cos. So I want to say 1 minus 2. But what is sine square? Look here, man, from the trig identity, which is sine square of x plus cos square of x equal to 1. Let's say I want to eliminate sine square. What is sine square? Sine square equal to 1. This will go over minus cos square. So sine square of x equal to 1 minus, this one's going to go over cos square of x. So I'm going to say 1 minus cos square of x, man. So I can say, okay, so if I don't want to have a sine x, for example, I'll say, okay, what is sine 1 minus cos square? So it's 1 minus cos square of x. And this is going to give us 1 multiply in 2 times 1, 2. Negative 2 times negative cos, going to be positive 2 cos square of x. So then this is going to give us 1 minus 2 is negative 1. So I can start with this because it's positive. So 2 cos square of x minus 1. And this is cos double angle. So this cos double angle could be written as this, or as this, or as this. One of them you could pick. So it depends how you want to use it. So let's see now how we're going to use it. Let's see how we can use it, man. So it's easy. So what I'm going to do, so like here, look. Let me try to make them in, okay. Man, How do you know you have what? Excuse me. What makes you sort of break down in that way? Look, if whenever see there's a power here, whenever you have a trigonometric, and there's a power, make sure you try to change your stuff in double angle. This is very important, right? Whenever you have a trigonometric, and there's a power, it doesn't matter which power, make sure you change to double angle. So how are we going to do that? Look here, man. So this power 3, and in double angle, I don't have power 3, I have it power 2. So I can use either this or this. So I have to break this into power 2. Either it's power 4 or either power 5. You just break into power 2. So I'm going to say, okay, so this MSA, so I'm going to take this face, then break down. So I say tag sine cube 5x. This MSA sine square 5x times sine 5x. It's the same thing. It's just like if somebody say x cube is same as say x squared times x power 1. So this same thing because this I'm like same base power 2 times 1 3. So it didn't make any change. So what we're gonna do now, you see, this is what I wanted. So what is sine square 5x? Look me, man. So we have this and this. Which one should I take? I'm gonna take this because this is the one having sine square. But look, so sine square of x, but this is sine square of 5x. So I'm gonna use this. Let me show you how I can use it. So it's like having cos 2x equal to 1 minus 2 sine square of x. So this now, look, square, but this is x, but this is 5x. Look, if this x, this is 2x. Excuse me. Say, put closer, man. Let me write down a little because some people seem like they can't see because of the light. Okay. So I'm going to take this. Let me write here. Cos 2x equal to 1 minus 2 sine square of x. So look here, man. If this is x, this is 2 times that angle. So whichever angle which is here is 2 times right here. So I'm going to say 5x. So it's like, okay, 5x. Look, how does it resemble to this same and this one? But this one is a 5. This one has a x. So if this, look, if I say sine 5x squared, what does that mean? You see, this is 5x now. If this was x, this is 2x. If this is 5x, this must be 10x. So it's going to be cos 10x. It comes in because it's always 2 times. So it's going to be 1 minus 2 exactly. So this is just like this, but now we want to put in the same form. But now we don't need this. We don't need the whole. We just need sine square of 5x. So we're going to make subject sine square of 5x. So we're going to say, okay, how are we going to make sine square of 5x? We're going to take all of this to the left. So it's going to be positive 2 sine square of 5x. And on the right you have a 1, and then you take this to the right. So minus cos 10x. So this is the one I need. And then divide by 2. So this and this cancel. So sine square 5x equal to 1 minus cos 10x over 2. So I'm going to take this and substitute in here. You know what I'm saying? I will have to substitute right there, man. I have to substitute right there, right here. Okay. So I'm going to read this stuff here, man, because I don't need it. So I'll just, okay, so I only need this part of the last one. So let's substitute it right now. So we're going to say this MSA equal to, so instead of say sine square, so say 1 minus cos 10x over 2. See, and they have a sine 5x. So sine cube 5x, I hope everybody can see there. It's kind of, there's a lot, but I hope you can see sine cube 5x equal to 1 minus cos da. So the next step, so what we're going to do here, we're going to say, okay, so now we can just multiply this. So sine 5 cubed times, when you multiply in, it's going to be sine 5x minus, when you multiply these two, it's going to give you cos 10x and sine 5x over 2. So this is same as say sine cube 5x. So what happened now? So instead of say sine cube 5x, I'll take this one in there. And why we do this, like I said, whenever you see the power and the sine of cos, make sure you put in that form of double angle, right? So what's going to follow next? So we're going to rate this one. So we can substitute in our integral. So my integral is going to become, so it's going to become integral, and then we're going to have a sine 5x minus cos 10x, and then sine 5x over 2 dx. It's easy, man. So what we're going to do now, I can take 2 outside. So 2 is going to come out, can factor out, because this is like 1 over 2. It's like, look, it's like 1 over 2. So 1 over 2 go out, and they'll have integral. So I can take the face one, I can separate. It's going to be sine of 5x dx. But these I have is for both, remember. So I put a bracket, and this is minus integral of the second one, cos, meaning this or second one, cos of 10x, and then sine 5x dx. So the equation is done. So what we're going to do then, we can integrate this. So this is easy because like we have integral sine 5x. So it's like integral sine 5x is easy, just like I said in the previous example. Okay, so we're going to say 1 over 2. Okay, so this is going to be 1 over the derivative of this function. When you derivate 5x, you're going to get only 5. And then when you integrate the whole sine of a function, you're going to get negative cos. So it's going to be negative cos of a function. A function is 5x. So minus, this is another case now. So here we have a cos 10x sine of 5x dx. Okay? So look here, man, this part here is very, very, very important, right? So this is another form of integral. Whenever you have an integration, and then look, there's no power, but there's a multiplication between. Listen, this is very, very important, man. You have an integration. In the integration, right here, look, you have a cos of angle times sine of angle, or cos of angle times cos of angle. As long as you have a sine and cos, and there's a multiplication between, you have to do factor formula of trigonometry. So I'm going to show you now how to do factor formula, right? So I'm going to raise the other party because we don't need him. So I'm going to raise this party here. I don't need this double angle anymore. So I'm going to show you now how to know the factor formula or how to do the factor formula of trigonometry. Easy. So factor formula, excuse me, I'll show you where the factor formula comes about or where it comes from. So the factor formula, if somebody, you have to know the double angle of trigonometry for you to remember factor formula. You don't have to memorize the factor formula because I see most of the students memorize factor formula, and sometimes it's easy to forget. So first of all, just know the compound formula. Compound formula, right, for both sine and cos. Okay, let's start with the sine. Compound formula of trigonometric, let's say sine of A plus B. Sine of A plus B, the same as say sine, this one you memorize. Sine of A cos B. Look, sine A cos B, start with the sine A cos B. And then this plus, right, plus here. And then what you do, switch it. So this is sine, right, cos here. So say cos, this is a trick I'm showing you. Cos, angle, leave it. And this is cos, right, sine here. It's going to be sine, and now angle, leave there how it is. Do the same thing, right? So sine, and they say minus here. Sine A minus B. So you do the same tricky. So sine AB, start with the sine again. Sine, what is the first angle? A. And then cos B. Sine, cos always, cos B. If this is minus, it should be minus also. And then what you do, you switch this. You see this? Cos and sine, switch them. Like this is sine and this is cos, switch them. But later, leave them. So it's going to be, you switch like this cos, come here, this sine, come here. So it's going to be cos of A, leave your angle the way how it is in the right position, the same position. And this cos is going to become sine. You see what I'm saying? So after that, what you're going to do, look, this is how the factor formula comes, right? What you're going to do, add them and subtract. Add them and subtract. So what you do for you to add or subtract, you look at what you have. You see what I'm saying? Look here. There's a cos and sine. Cos and sine. Cos and sine. So you look at which one has a cos and sine. Cos and then sine. This sine cos. This sine cos. But this is cos sine, cos sine. Okay. So this is the one I need. This is the one I need. You get what I'm saying? So now think, which should I plus or minus so that I'm led to this part? If I minus, look, if I minus, it's not going to give me the right thing, because look, if you minus, it's going to be sine A cos B minus sine A cos B, this is going to cancel. Which is true, yeah, I think this is true. If we minus, this and this is going to disappear, because look, you minus the tops, minus the bottom. If I minus this top and the bottom, this and this is going to disappear, because this is plus, minus plus gonna disappear. See, so it's gonna give us this. But if you add, look, if you add, what happened? It's gonna be this and this gonna come, but this is gonna disappear because it's gonna be plus cos A sin B, and there's gonna be plus minus. So this is gonna disappear, and we need this. So we don't have to plus, we have to minus for this case. So it so depends what you have here. You know what I'm saying? So now look. So since I want this, how did I know I want this? Because cos, sine, cos and sine. So this is cos and sine, cos and sine. So I'm gonna say minus. Why minus? Look. So this is gonna give us, excuse me. So this is gonna give us sine A plus B minus this means top minus bottom. Sine A minus B and sine A cos B minus sine A. This and this is going to cancel because positive minus positive cancel. They're the same. The same. So they're going to cancel. But the second one, no, it's not going to cancel because it's going to be plus cos A sin B minus, which is going to be plus. It's going to be 2 of them. 2 cos A sin A. Cos A sin B, my apologies. This is sin B. Sorry. This is sin B. I forgot it here. This must be B. So cos A sin B. So what you want? You want cos sine. Means I need this. So I have to divide by 2. And then I have to divide by 2. So what's final then? This and this cancel. This and this cancel. So finally I'm going to have a cos A sin B. Let me switch them. So cos A sin B. Excuse me. Cos A sin B. So my final answer is going to be, no, for this part here is going to be cos A sin B. So it's going to be cos A sin B. Like I started with this one. I start on the right and then I'll go to the left. Cos A sin B equal to sin A plus B minus sin A minus B, which is this one, then over 2. So what that mean? Look here, man. So now we say, look. So what is a A? A is 10x. And what is a B? B is 5x. So we're going to say cos. What is A? 10x. Sine. What is a B? B is 5x. Equal sine. We're looking for this. What is a A plus B? 10x plus 5x, 15x. And they have minus. Sine A minus B means 10 minus 5x, which is going to be sine of 5x. And then over 2. So instead of writing this, we're going to substitute this one here. The value of this and this one. So we're going to take that one right there and then it's going to come into there. So what we're going to do right here, man, we're going to say this part is done. So we're going to say, what are we going to raise here, man? So I'm going to say, okay. So minus, so this is going to say the same how it is, means, the same how it is means 1 over 2, negative 1 over 5, cos 5x, there's a negative here. And then, so this is going to be, exactly it's going to come here, but I can take 2 outside of here. It's going to be 1 over 2 and then integral of the first one. So I can put a little bracket here. What is the first one? Sine of 15x dx, and then minus the second one. Integral of sine of 5x dx. But remember I have the 1 over 2. But all of them multiply by half. There's a bigger bracket here. All of them multiply by half. So now the question is done. So I can just erase on top then finish. I don't need this anymore. I mean the factor formula of trigonometry. We call it factor formula here, right? But I don't need it anymore because we know it. Factor formula of trigonometry. Factor formula. I don't need it anymore because I know. So I'm going to rate the factor formula. So it's okay. So let me rate the factor formula because I don't need this part here. We know it. So let's just rate the factor formula, man. We don't need it for now. Praise. Okay, so we don't need the factor formula. So finally, we're going to say, so, excuse me. I think I can even raise here because the space is not going to be enough. Okay, let's take this one. So this is going to give us, man, the space is not going to be enough, man. So I'm going to have to raise some of the part. I'm going to raise here and then I'll write again. Don't worry about it. Let me take it. Okay, so, oh man, the space is not enough. Okay, so I'm going to raise on top here. I hope you don't mind because you have all the wakes. Okay, so now we're going to have, a 1 over 2 bracket and then negative 1 over 5. And then we have a cos 5x and then we have a minus a half. Okay, so this is easy. So now we're going to do the same strategy, sine of a function. What we're going to do, we're going to differentiate the function, which is going to be 1 over, when you differentiate 15x, is going to give us 15. And then when you integrate the sine of 5x, we're going to get negative cos of 15x. Negative cos of 15x. Now we go for the second one, we do the same strategy, minus. So this is going to be, you differentiate 1 over, differentiate 5x, you're going to get is 5. And then, so now when you integrate the sine of 5x, it's going to give us negative cos. So which is going to make this positive because it's going to be negative cos of 5x, which is going to give us cos. And then put your bracket and the bracket for this one outside. So now the question is done. So we can just simplify. Plus constant c. Don't forget to plus constant c because the question is done and there's no limit. So you have to make sure you plus constant c. So now this is going to be 1 over 2. Let's simplify the inside of 1. So negative 1 over 5 and then cos of 5x. Now multiply that out. So this is going to be negative 1 over 30. And then this is going to be cos of 5x. This negative is like a positive. So negative half times negative 5 is going to be plus, no, negative, excuse me. It's going to be negative because this is going to be plus already. So negative a half times negative 1 over 5 is going to be negative 1 over 10. And this is going to be cos of 5x plus constant c. So then, I think the question is done, man. Do you have anything? No, this is wrong here. It's 15. Cos 15, excuse me. This is 15 right there, man. I say 5. This one is 15. Look, it's 15. It's 15, man. So it's like 15 here. Cos of 15. Exactly how it is. 15x. So we see some of the stuff are same here. For example, this one. This and this are the same. So negative 1 over 10 minus negative 1 over 5 minus 1 over 10. So negative 1 over 5 minus 1 over 10. So plug it there. So we say negative 1 over 5, negative 1 over 5, and then try to calculate it quick, minus 1 over 10, minus 1 over 10. So we get negative 3 over 10. So these are the same because look, 5x and this 5x. So it's going to be negative what? Negative 3 over 10. So these together are going to give us negative 3 over 10. So we're going to say, so it's going to give us, let me just try to erase here. So this is going to give us a half negative 3 over 10, which is cos of 5x. Cos of 5x and negative 1 over 30, cos of 15x. So I'm saying then plus constant, then it's done, man. So I can multiply that out. So this is going to get equal, finally, our final answer. So when you integrate, means when you integrate, excuse me, sine cube 5x dx, you get, multiply that out. So this is going to be negative 3 over 20 cos of 5x. This and this one, a half times negative a half is going to be negative 1 over 60 cos of 15x. Plus constant. And that's how you do it, man. Look here, man. If you FaceTime my channel, man, you know, if you FaceTime my channel, try to share with a lot of people, you know what I'm saying? This program is for the women, right? So if you have a sister, mom, auntie, grandma, friends, neighbor, your girlfriend, your wife, try to share with them, man, you know what I'm saying? The aim is just to motivate large men and women that we can, you know what I'm saying? Because, you know, we believe it, you know, women can change, they can spark this universe, man. So, man, brother out there, man, cousin out there, uncle, brother, cousin, you know what I'm saying? Try to share with our little sister, with our little mom, and everybody, man. Thanks a lot, man, for your time, man. Don't forget to click that subscription button. And this is how you solve it, man.